Welcome to This Explainer. Have you ever looked up at the night sky and just wondered if humanity could actually settle on another planet? We talk a whole lot about the giant rockets that'll eventually get us to Mars, sure, but there is a massive, honestly often overlooked engineering challenge waiting for us once we actually touch down. How exactly are we going to build entire cities on a barren, frozen world? Okay, let's dive into this. We're unpacking the ultimate cosmic construction project today.
So, here's a fascinating question for you. Would you like to settle on Mars? It sounds like an incredible adventure, right? But hey, before you pack your bags, who's actually going to build the houses, pave the roads, and string up the power grids before you even get there? You can't exactly just pitch a camping tent on the red planet and call it a day. Establishing a permanent human presence means laying down an entire civilization's worth of infrastructure, literally from absolute scratch. To figure out exactly how we do this, we're going to follow a step-by-step cosmic construction blueprint. We'll start by sizing up the Mars engineering challenge, then move on to 3D printed homes, powering the planet, unlocking water and food, unleashing a robotic workforce, and finally, building that very first city.
Let's start with Section 1, the Mars Engineering Challenge.
So before we can even think about laying a single brick, we really need to understand the sheer, mind-boggling scale of our blank, frozen canvas. We're talking about a world roughly 225 million kilometers away from Earth. Now, why does that matter so much for engineers? Well, because traditional construction logistics are utterly impossible here. You can't exactly load up a fleet of heavy trucks with cement and steel beams and just ship them across the solar system, right? The transportation costs alone make bringing Earth materials totally unfeasible. So we've got to figure out how to build with what's already waiting for us there.
And honestly, when we finally get there, the greeting isn't exactly warm. We're met with an average temperature of negative 60 degrees Celsius. To put that into perspective, that's colder than a deep winter night down in Antarctica. This brutal extreme just underscores the incredibly harsh conditions engineers have to outsmart. Everyday materials behave entirely differently in this kind of deep freeze. They get super brittle and they're incredibly prone to snapping. Plus, human workers obviously can't be out there swinging hammers in a freezing, deadly vacuum.
So the crucial point is this. Earth provides us with a really welcoming environment, right? Abundant oxygen, making life and building pretty convenient. Mars, on the flip side, gives us brutal cold, a remarkably thin atmosphere, and almost zero oxygen to actually breathe. We aren't just building structures here. We literally have to engineer an entirely new, enclosed, life-supporting infrastructure from the ground up just to keep those very first brave settlers alive.
Moving right along to Section 2. Step 1. 3D printed homes.
Okay, since we've already established that we absolutely cannot bring a cement truck from Earth, how do we actually build our shelters? Well, the answer literally lies right in the ground beneath our boots. Engineers are planning to use something called regolith. That's the loose, dusty Martian soil you see everywhere in the photos. Instead of trying to fight the planet, we're going to scoop up the Martian terrain itself and transform it into our homes.
Let's move to and see how this builds out in the actual construction sequence. Step 1. Robots arrive first to prep the site. Step 2. These specialized automated machines start mining and processing that regolith. They'll often bake it or mix it with special polymer binders to create this super durable, almost concrete-like ink. And then Step 3. Giant automated 3D printers layer that processed dirt to print these massive structures. And get this, those walls are going to be remarkably thick. They're engineered specifically like that to block deadly galactic cosmic radiation, which otherwise would just punch right through Mars's super thin atmosphere.
All right, that brings us to Section 3, powering the red planet. So, you've got your fancy 3D printed shelter, but without power, let's be real, it's basically just a cold, dark cave. Establishing a bulletproof power grid is our next critical utility, and we've got two main contenders here. Now, what's really interesting about this slide is the trade-off. Solar panels seem like a no-brainer, right? But Mars is notorious for massive, literal planet-wide dust storms that can completely block out the sun for days, sometimes even weeks. Small nuclear reactors, on the other hand, provide continuous, reliable energy day and night, no matter what the weather's doing outside. So to make absolutely sure the colony never goes dark, engineers have realized that the future Martian city is going to absolutely require a hybrid grid, using both solar and nuclear energy.
Next up, Section 4, unlocking water and food.
Okay, so we've got shelter, we've got power, but how on Earth, or rather, how on Mars, do engineers conjure up water out of a totally dusty, barren wasteland? Well, while there isn't any liquid water on the surface, there is an absolute abundance of ice.
And this brilliantly illustrates the plan. Specially engineered machinery is going to first locate and extract that underground or polar ice. Then, they'll melt it down and process it into a usable liquid form. And listen, this water isn't just for drinking. It is the literal lifeblood of the entire colony. We're talking using it for farming and, crucially, splitting it into hydrogen and oxygen. We are literally engineering the very air we're going to breathe.
Naturally, all that precious water feeds straight into our agriculture. I mean, if humans are moving there long-term, we can't just be eating freeze-dried foil packets shipped from Earth for the rest of our lives, right? True survival relies on specially engineered greenhouses, all built with perfectly locked-down temperature, light, and moisture controls. Now, here's a crazy fact. Raw Martian soil actually contains these toxic chemicals called perchlorates, so we can't just plant seeds in the ground. Instead, we'll rely on super advanced hydroponic and aeroponic techniques. That means we're growing massive amounts of crops entirely without dirt, just using nutrient-rich water. Future settlers will actually cultivate fresh tomatoes, potatoes, and lettuce right there on the red planet.
Which leads us directly into Section 5, the robotic workforce.
As we mentioned earlier, the Martian environment is initially way too hostile for human construction workers to be out there in hard hats. So, this entire blueprint hinges on a labor force that, quite frankly, doesn't need to breathe. Long before the very first human sets a single boot on this new colony, an entire army of AI-driven robots is going to be hard at work. We're talking robots out there paving the roads, installing vast fields of solar arrays, extracting the underground ice, and operating those giant 3D printers we just talked about. Seriously, artificial intelligence and advanced robotics, they are the absolute backbone of this entire engineering feat.
Now, to tie all of these automated tasks together, the engineering blueprint maps out a really robust transport system. You'll see things like electric rovers and slick automated vehicles, but perhaps the most fascinating part of all this is the realization that a lot of civil engineering on Mars will actually happen downward rather than upward. Constructing a sprawling network of underground tunnels is honestly one of the smartest possible ways to travel and live there. It offers a natural, basically impenetrable layer of solid rock to protect both our robots and, eventually, our humans from deep space radiation and those incredibly blinding surface dust storms.
And finally, we arrive at Section 6, building the first city.
This is it. This is the triumphant climax of our entire blueprint, where all of these insanely complex engineering layers finally combine into a living, breathing, functioning metropolis. Just picture it for a second. A sprawling city made up of transparent domes, massive fields of glowing solar panels right alongside humming little nuclear reactors, bustling, fully automated robots just seamlessly maintaining all the infrastructure, and these lush, vibrant greenhouses providing fresh, real food. And remember, this isn't some scene from a big-budget science fiction movie. This is a literal, calculated engineering goal that scientists and engineers are actively working toward right this second.
But to actually make this a reality, it's going to require an absolutely immense, highly collaborative, multidisciplinary effort. It's going to take brilliant civil engineering to design the structures, robotics and artificial intelligence to physically build them, super advanced energy systems to power the whole operation, and of course, cutting-edge space technology just to get us all there in the first place. The engineers tackling these specific fields right now are arguably the most vital pioneers in what is easily going to be human history's greatest project. So, after seeing all this incredible ingenuity, the 3D printed dirt homes, those massive underground tunnel networks, and the robotic armies completely required to make this barren rock somehow habitable, I've got to ask you one last time. Are you ready to pack your bags for the Red Planet?